Architectural patterns in game development. Software architecture of a program is an early stage of the system design process. It represents the link between specification and design processes. It is often carried out in parallel with some specification activities, and it involves identifying the major components and their communications. Advantages of software design is that it describes and plans for the expected gameplay features. It gives us a rational framework within which we can make any required change. Game abstraction emphasizes on the idea and the properties rather than how it works, and it greatly reduces the complexity in large programs by hiding the irrelevant details. Hardware abstraction is necessary because for every platform of hardware configuration with different graphic cards, sound cards, these codes have to be written and linked through the common interface. Hard and soft architecture. Hard architecture is the horizontal solution, and it is an architectural model in which subsystems interface with the computer hardware and the player. Soft architecture is the vertical solution which actually makes the game and is domain specific. It's generally not reusable between game projects. There are 4 tiers of game architectures: input and output devices, device APIs, main, and data. It is impossible to represent all relevant information in a single architectural model, as each model only shows one view or perspective of the system. A logical view shows the key abstractions in the system as objects or object classes. Process view shows how at runtime the system is composed of interacting processes. A development view which shows how the software is decomposed for development, that is, it shows the breakdown of the software. A physical view which shows the system hardware and software components are distributed across the processors in the system. This view is useful for system engineers planning a system deployment.
Now we'll be looking at some of the architectural patterns that can be used for game development. So starting off, we'll be seeing MVC pattern. The MVC pattern is widely popular these days, mainly for web app development or mobile development. So what MVC stands for is model, view, and controller. So the basic idea here is to separate each system into 3 classes: the model class, view class, and the controller class. The view class consists of all the graphics that everything that is rendered on the screen to the user. So suppose if you're making an Android application, your fragments, your activities, those things go into the view class. If you're making a game, then all the graphics rendering would go in the view class. Next comes up the model class. So that consists of all the data and all the manipulation that is done on the data. So all your logic is going to go in this class, the model class. And finally, we have the controller class, and that acts as an interface between the model class and the view class, and it reacts to all the user interactions like mouse click or keyboard or whatever that is required, and it takes the data flow to the appropriate place, the model class or the view class. So now we'll see why MVC is a viable option for game development. So a game is basically an iteration of the environment reacting to user interactions or some other events based on other entities of the game. So now this is closely it can be related to MVC, but there are a few issues here. So first of all, like in a game, there'll be a lot of reusable code. So, and these are basically functionalities that are like a chop up, not a chop up, but like additional functionalities to the entities of the game. So these functionalities don't really fall into any of the 3 categories, the model, view, or controller. So we need something else that is fairly covered in the pattern called EC, that stands for entity component. So the component part stands for what I'm describing here. The next issue we face is if you're implementing an MVC pattern for a game development project, then the references to the MVC classes would get scattered throughout the code. So we need a single place, a single entry point from where we can just access everything through the code. So how to overcome these issues? So basically we can alter the MVC pattern to what is known as AMVCC, that stands for Application Model View Controller Component. This is similar to MVC with just a few the two additional things here that overcomes the two issues specified before. The application part here is a class that is a single entry point that contains the base classes for all the model views and controllers. So all the MVC classes therefore in the application will be extending the base classes, and they can be directly referenced through this application class. And the C part, the component, that is usually small scripts that are individual, independent, and it just takes in an entity and performs a set of operations on it. So for example, it could be just accelerating an entity, so that could be a utility, that is a component. Another example could be rotation. So if you just give any entity to the function, then it would just add an angular velocity to the entity, and that's all. It would not store or notify or do anything else. That is it. So this is how we can use MVC.
The next architecture that can be used in game development is layered architecture. It simply organizes the system into layers with related functionalities associated with each layer. And it is also the way of achieving separation and independence, where each layer only relies on the facilities and services that are offered by the layer immediately beneath it. Now, when can we use this layered architecture? So the best scenarios can be when we are building new facilities on top of the existing systems, or when there is a requirement for multi-level security, or when there is a development that is spread across several teams and each team has the responsibility for a layer of functionality. This architecture works well. Now here is an example for simple 4-layered architecture in which the lowest layer includes the system support, that is operating system or databases or etc. The next layer has the system utilities or application functionalities. The third layer such as the user interface management, that is like functions for authentication or authorization, and the top layer provides the user interface facilities. Now, how we can collaborate this layered architecture with game development and how we can use this in practice. So if we think of a game and if we want to use the layer architecture for the same, we can simply have a scenario of 3 layers where the base layer consists of a game engine like Unity or Torque or Unreal game engine and database that is unique to that game. In second layer, we can think of having a general behavior of the game depending on the application, like firing of guns or movement of vehicles, or if we are having any car racing based game, then taking a turn or going straight kind of moves, this kind of general behavior can be encapsulated in layer 2. And on the top layer, the handling based on user interaction with the game can be implemented. Now, the pros and cons for the layered architecture. The main advantage can be that it allows the replacement of entire layers as long as the interface is not changed. And also the redundant facilities, like if we want to add authentication in each layer, then we can do that also with layered architecture. And this kind of architecture is desirable when the number of modules grows to be large and keeping track of individual dependency between the modules becomes too difficult. And the con can be when the separation between layer is difficult and high level layer may have to interact directly with the lower layer layers. Then the task of layer architecture becomes difficult.
Let's look at the client-server architecture. The client-server architecture is a very commonly used runtime organization for distributed systems. The motivation to use client-server architecture comes from the use of a traditional peer-to-peer model for real-time systems. For real-time games, each player inputs such as key presses were exchanged with other peers, and before any player could simulate a frame, all other players' key presses needed to be received, and that created latency in the system. So in order to avoid that, the client-server model in client-server model, instead of each player running the same game code and communicating directly with each other, each player was now a client and they all communicated with just one computer called the server. The major components of this model are a set of servers that offer services to other components, a set of clients that call on the services offered by servers. There will normally be several instances of client program executing concurrently on different computers. A network. The third component is a network that allows the clients to access these services. Most client server systems are implemented as distributed systems connected using Internet protocols. The architecture is suggested to provide the following qualities. Because the server is trusted with the state of the game, it is a cheat resistant. The loose coupling of game code with network code allows flexibility and extensibility. Since the client runs the subset of the game code for its character, means every computer simulates the game for the player, the character that plays on the game, so it involves low bandwidth. The examples of the client server example of the games that use client server architecture are Call of Duty Modern Warfare and QuakeWord. The advantages of the client server architecture are maintainability. It is possible to replace, repair, upgrade, or even relocate a server while its clients remain both unaware and unaffected by the change. All the data is stored on the servers, which generally have better security protocols than most clients. Servers can better control access and resources to guarantee that only those clients with appropriate permissions may access and change data. The disadvantages include susceptible to denial of services attack or server failure because there are multiple services involved, unpredictable performance due to system and network dependability, management problems. If servers are managed by different organizations, there might be some conflicts and it may.
Repository architecture. As the name suggests, it contains a central repository which manages all the data in the system. All the component interacts through the repository for the data, so the component do not need to interact with each other. This type of architecture is best when there is a large amount of data which needs to be generated and persisted for a long time. So let's see how repository architecture works with game development. Here we take the example of EA FIFA. FIFA is a multiplayer sports game which simulates real-time soccer. It has various sections such as campaign mode, story mode, online gaming, squad management, etc. All these sections generates lots of data that needs to be persisted and used again by the same in different sections. This architecture can be implemented using repository architecture pattern where all data can be stored in a single repository. All the sections then can be query the repository for the data that is needed. There are some advantages and disadvantages of this architecture. Let's look at the advantage of this architecture. Advantage of this architecture is that each component is independent of each other. Changes made by one component can be propagated by all the components. All data can be managed consistently as it is all in one place. The disadvantage of this repository is that this repository is a single point of failure. So problem in the repository affect the whole system. Distributing the repository across several computers to prevent this type of damage, it is also very difficult.
Pipe and filter architecture. Pipes and filter consist of a chain of processes or other data processing entities arranged so that the output of each element of the chain is the input of the next. Data flows from one to another and is transformed as it moves through the sequence. Each processing step is implemented as a transform. Input data flows through these transforms until converted to output. The transformations may be executed sequentially or in parallel. The filters in pipe and filter architecture works all at the same time. The architecture is often used as a simple sequence, but it may be also very useful for complex structures. These are the pipe and architecture elements. The first, as you can see, is the class of filter. The filter transforms or filters the data it receives via the pipe with which it is connected. A filter can have any number of input pipes and any number of output pipes. Second is the pipe, which is also called as connector, that passes data from one filter to the next. It is directional stream of data that is usually implemented by a data buffer to store all data until the next filter has time to process it. The third one is the data source, or producer is the data source. It can be a static text file or a keyboard input device, continuously creating new data. The last is the sink, or consumer is the target data. It can be another file, a database, or a computer screen. Now we will discuss the advantages of pipe and filter systems. First is the simplicity. Pipe and filter architecture is much simpler than the other architectures, as it allows designer to understand overall input behavior and output behavior of the system